Okay, so these calculations to determine buck boost transformer ratings can seem pretty complicated, but they're actually fairly simple once you understand what's going on with them. So to find the rating of the buck boost transformer, you will need the input circuit voltage, and you'll need your output voltage rating. That's the voltage that you actually have available at the leads of the transformer, and then the desired voltage on the output. So in question 7 here in 242.2, um, says a blank kVA transformer, blank kVA 240 or 480 volt to 24 48 volt transformer that is connected to a 277 volt circuit should be used to operate a 230 volt single phase motor that draws 25 amps. So our input circuit voltage is 277 volts. Our output voltage rating is 230 volts. So we take that 277 minus 230, and then that gives us 47. And then we divide 47 by 277, the input circuit voltage. And what we're doing there is we're basically giving ourselves the portion of the voltage that buck boost transformer is carrying, um, expressed in a decimal form. So that gives us 0.17 after rounding, uh, and then we're going to multiply that by the kVA rating of the load. So that's going to be 230 volts because that's the voltage that we're going to be running the load at, times 25 amps rated current of the load, and then we're dividing that by 1,000 so that we can get that into kVA, because just 230 times 25 would give us our answer in volt amps, which we do not need here. So we take that 0.17 times 5750, which is our kVA rating of our load, and that should give us somewhere just underneath 1 kVA. So we're going to need a 1 kVA rated transformer for this load. Now, this example here is for a buck transformer because we are dropping down from 277 to 230 volts. We're bucking voltage, but it's a very similar formula for if we were using this as a boost transformer. Say we were trying to we only had 230 volts and we needed 277. Really, the only difference in this entire thing would be that now this would be the output voltage rating, and this would be the input circuit voltage. We would still subtract the smaller from the larger, and then we would still divide that number by the larger of those two, and then we would be multiplying it now by 277 times 25 amps to get our kVA. So, and just a quick recap. All we've really done here is we've determined in decimal form what portion of the voltage the buck boost transformer is supplying, and then that corresponds to the portion of the current and therefore the portion of the total power that the transformer is carrying. So once we get that in a decimal form, we're able to just multiply it by the total kVA rating of the load to figure out how big the buck boost transformer itself needs to be. Um, and then again, this same formula here, just with using output voltage rating minus input circuit voltage, and then dividing that by the output voltage rating. That would be what you would need to do for questions such as question 10 over there, where you're trying to go from 190 volts up to 208 volts, meaning that would be a boost configuration there. You're boosting the voltage. And then I wanted to point out one last thing here. this 240, 480 volt, 24, 48 volt transformer. That could be the same transformer as the one in questions 1 through 5 there. In those in these configurations up here, though, these are not being used as an auto transformer. They're just being used as isolation transformers. Using them as a buck boost transformer, though, would be as simple as, say, taking a jumper from here to here, and then we'd no longer be taking our load from here to here. We'd now be taking our load from, say, here and here. Right. So same transformer, but it shows the drastically different uses you can get out of that one versatile buck boost transformer. We can use that transformer to get 24 or 48 volts out of 240 or 480, or we can use that same exact transformer to get 230 volts out of 277 volts. Very versatile and cool pieces of equipment.